Okay, question 5 was really quite tricky, and it did require you to spot a couple of tricks in order to answer it. But the first one really required you to notice that if you differentiate the bottom, then we get the top, i.e. you differentiate the bottom, the 1 disappears, and you're just left with e to the power of x. How does that affect it? Well, that means we can do ln of 1 plus e to the power of x. Is that our final answer? Well, it's always worth just checking what happens if we differentiate it. So if f of x equals ln 1 plus e to the power of x, what happens for the derivative? Well, with the chain rule, we differentiate the whole function, and it becomes 1 over 1 plus e to the power of x times by the derivative of the inside of the function. Differentiate the 1, it disappears. Differentiate the e to the power of x, it stays e to the power of x. So this particular function does differentiate to e to the power of x over 1 plus e to the power of x, which is what we wanted with our original equation, which means our answer here was correct. Again, part B did involve a little bit of a trick, and it required you to spot that this is fairly similar to our double angle formula for sine. So I'm going to write that out as it is in your formula booklet. Sine 2 theta equals 2 sine theta cos theta. Now what happens if we replace theta with 3x? Well, that means we get sine 2 theta becomes sine 6x equals 2 sine 3x cos 3x. Oh dear, my whiteboard is not very good today. Cos 3x. There we go. But we don't want 2 lots of this, we only want 1, so we half it like so. That means this question boils down to a case of just integrating sine 6x all divided by 2 dx. Well, what happens when we integrate sine? It becomes minus cosine 6x, and we then have to divide by 6, because when we differentiate the 6x, or differentiate the cos 6x, it becomes minus plus sine, and then we multiply by 6, and we need to cancel that out. So our final answer becomes minus cos 6x divided by 12 and plus c. And there we go.